Testing. Hey, the three boys at the front, please. Okay, live continue as usual. We will continue where Mr. Spua has left off. Today we will try to examine some of the chemical reactions for alcohols. Okay, I think she went over this part, but since it falls under the premises of chemical reaction, maybe I'll go through the first two like quite fast. Alcohols can be used to produce alkene, excess concentrated sulfuric acid, and heat. Okay. Since it involves the removal of water, you can call this a dehydration reaction. Okay, let's give a harder alcohol to work with. Now, when you want to remove water from an alcohol, first you locate the position of the OH, then you look around for neighboring hydrogen in which the OH and the H can come out as the water, right? So, if you look at this example, there should be two products being formed in terms of different structure. One major and one minor. What law is this? Or what rule is this? Zizef rule, yes. So the major, or Zizef rule. Okay, never mind. Okay, so the major product is the one with more alkyl groups. Okay, I think on the screen it appears very light pink. Okay, for the minor product, it has only one alkyl group. Okay, the next slide, I think this is where she ended talking about ether formation. So, if you have two alcohol molecules side by side and in the presence of excess sulfuric acid and heat, it will be an intermolecular reaction whereby one party, that means one OH will provide the OH, the other alcohol molecule will provide the H to remove water as well, and you get that molecule at the bottom, and this molecule has a name. Okay, it belongs to the ether functional group, which is not in your Chem H2 syllabus, but you should be able to recognize the functional group. It is C single bond O and single bond C. That means COC. Okay, COC. So this is called an ether functional group. This is where she ended, and then this is the new part today that we are going to learn. We will convert your alcohol into alkyl halide, which was the topic before this. Okay? And there are three reagents and conditions you should memorize as shown on slide A, B, and C. Yeah? So the first one is HX, second one is PX3, or you may use PX5 later, I will show you on the slide. And the last one is SOCl2. Let's examine part A first, hydrogen halide. So, when you heat an alcohol molecule with hydrogen halide, or let's say you heat with hydrogen chloride, you will get RCl plus H2O. Notice the balance equation, your OH now is substituted by a X. So you have successfully converted an alcohol functional group into a alkyl halide functional group. Okay? So these are the reagents and conditions. You can use the HX gas and heat, or you prepare the HX gas in situ. What is in situ? That means during the reaction, you produce the HX gas, then the HX gas will go and react with the ROH molecule. Why do we not want to use HX gas at the start of the chemical reaction? The reason is very simple. Handling of gases is not so convenient, correct or not? That means you need to mix the gas and the ROH, which is a liquid, together, then you let the reaction take place. Right? Handling of gas is not very convenient, and HX gas itself is toxic. Okay, HX, when they dissolve in water, becomes a strong acid, right? Correct or not? So imagine if you breathe in HX gas, what do you think will happen? It will dissolve in your saliva or your mucus. Then, you know, if your skin has a few drops of acid drop onto it, what do you normally feel in lab? The teacher will ask you to wash your hands quickly or wash your skin under copious amounts of water. You'll feel itchy, right? Correct or not? So the same thing will happen if you breathe in HX gas, right? Because HX is a strong acid. So how do we produce HX gas during the course of the reaction? That means we do not immediately react the ROH molecules with HX. We can produce HX using a balance equation as shown at the bottom of this slide. We will use sodium chloride. Sodium chloride is quite a stable ionic salt. Okay, so this ionic salt you react with sulfuric acid, in fact corn sulfuric acid. And in the process, it will give you HCl gas. So what does that mean? So instead of reacting ROH with HCl, right, what do I react? I react ROH with NaCl in the presence of corn sulfuric acid. So the corn sulfuric acid and the NaCl will produce your HCl, and the HCl will then go and react with your ROH to convert the ROH into RCl. So that is for part A. Instead of using HCl gas and heat, you can use PX3. Let's say you want to convert ROH into RCl. I will react it with PCl3. This can happen at room temperature, which means this part B or second equation compared to the first method, this equation do not need heating, right? Because in it is written as room temperature. So an example, what do you get when you get CH3, CH2OH and PBr3? You will get CH3, CH2, Br, and the side product is a phosphorus acid. Okay, this is using PX3. If the X is a Cl, instead of using PCl3, there's another option, which is in the next slide. It is PCl5. It has the same ability to convert ROH into RCl. What is different for this slide and the previous slide is the side products are a bit different, right? Can notice or not? Now the side product is HCl and POCl3. The previous one is like it's a phosphorus acid, remember? So then we can notice something about the side products, okay? But first, let me give you an example. You should be able to write down the products of this reaction when you react with PCl5. So in this case, CH3, CH2OH will be converted into CH3, CH2Cl, okay? Then the side product will be HCl and POCl3. Now, what can you observe in the lab? You can observe white fumes of HCl. In other words, if you react with PX3, there will not be white fumes because the side product is not HCl gas. Okay, the last way to convert ROH into RX is to react it with SOCl2. Again, you convert ROH into RCl, conversion of alcohol into alkyl halide. The side products are a bit different. Just now was POCl3 and HCl. Now is SO2 and HCl. So only one of the side products is the same, which is HCl, right? The other side product is different, right? But the experimental observation is almost the same, white fumes, because the previous one also had white fumes, right? The white fumes correspond to the HCl being produced. So there's an advantage of using part C, which is this method here. The advantage is the side products, if you recognize, SO2, which you have done in preg, is the one that turns The purple KMNO4 colorless, remember or not? SO2 is a gas, HCl is also a gas. So why does gas help in this case? Because normally the desired product of any organic synthesis is your organic product. In this case, is your RCl, right? Your SO2 and HCl are your side product, correct or not? So if I want to do a purification process using this chemical reaction, right, I can easily remove my SO2 and HCl because since they are gases, right, I can heat up, then the gases will be driven off. Then hopefully I have some things to collect the gases that I've driven off. So up to now, let's recall, how many ways are you expected to memorize to convert ROH into RCl? How many ways? 3 ways. First way, react with HCl gas, correct or not? Second way, react with PCl3 or PCl5. Third way, react with SOCl2. 3 ways, right? A, B, C. Okay. Now, there is an application for this reaction. So when you react with PCl5 and SOCl2, right, remember what is the observation that I keep harping on? Dense white fumes. What is the identity of the dense white fumes? HCl, right? So what is the use of this dense white fumes observation? So to jump ahead a bit, phenol I'm not expected to cover today, but phenol will be taught at the end of the alcohol set of notes. So if you look at this reaction, right, normal aliphatic alcohol can react with PCl5 to give out HCl gas as a side product, but phenol is unable. So what is the observation that you should record? Let's say for a simple chemical test to distinguish between a propanol and a phenol. So you say react with PCl5. Then what's the observation? Dense white fumes observed. No dense white fumes. Get the idea or not? So that is a distinguishing test. Okay? As to why phenol cannot react with PCl5, it will not be covered in this lecture. Okay? But I can jump ahead a bit and tell you that the CO bond in phenol is much stronger than the CO bond in a normal aliphatic alcohol. Okay, huh? Okay, other reactions of alcohol. Just now, if you realize, we were substituting away the whole OH, right? Correct or not? By a halogen X, or substituting ROH to convert into RCl, correct or not? Now I'm only targeting the H. Can see not? Because I'm breaking the OH bond. Just now was breaking the CO bond. So what are the reactions that target the OH bond? There are 2 that you have to understand and apply. Reactive metals and condensation reaction. Okay, this one, I think you have learned of this in lower sec already, because you know when you throw a reactive group 1 metal like sodium into water, what do you get? You get hydrogen gas, right? Correct or not? Hydrogen gas. Then I think you already played with it in practical 3 or practical 2. Gives a pop sound with lighted spleen, correct or not? So, can you tell me what is RO minus Na plus? What do you expect the state symbol to be? Solid, liquid, or gas? Solid, liquid, or gas? It is an ionic compound, right? You look at the name, sodium alkoxide, like sodium chloride, correct or not? Ionic compounds are most likely to be solid under RTP, correct or not? So if I were to conduct this experiment, I throw sodium metal into alcohol. At the end of the reaction, I would notice a solid at the bottom of my glassware, okay, because it is sodium ionic compound. Okay, I also want you to take note of the mole ratio because it may help you with one of the checkpoint questions later. Hydrogen gas is H2, right? 1 OH group will only give you half H2. Okay, 1 OH will only give you half H2. Then you ask me what's so important. Later you realize, okay? So what do we call this reaction? Acid metal reaction. H2 gas can be confirmed. Pop sound with a lighted spleen. So you are expected to know how to balance this equation. Given to you. Ethanol react with sodium. You get sodium alkoxide is the generic name. So if it's ethanol, what do you think is the name? Sodium what? Ethoxide. And H2 gas, for those that are interested in know the name, is sodium ethoxide. Okay? Okay, checkpoint. Can you see the checkpoint? Can you tell me what's the answer? You should be able to do this in less than 5 seconds if your mole ratio is good and if you know what is optical activity. Five seconds, come. Optically active. 1 mole of hydrogen gas. Okay. There are 2 conditions being imposed on this question. First, okay, let's do the more recent one that you will memorize because I hinted to you. Just now I was saying 1 OH will give you how many moles of H2 gas? Half. So in order to get 1 mole of hydrogen gas, how many OH I must have? 2, which narrow down my choices to C or D, right? C or D, right? So first condition I satisfy. What's the second condition? Optically active. Optically active, you must hunt for a chiral carbon. So out of C and D, which one has a chiral carbon? You should be able to do it. Answer is C. You should be able to do it in less than 5 seconds. Quite easy, right? Okay, then, okay, to make sure you understand, can you tell me which one is the chiral carbon, counting from the left? Which one is the chiral carbon? From the left. Hey, which one? 1, 2, 3, 4, come. Which one? Don't know how to read condensed formula, is it? The answer is the second carbon from the left. Because the carbon is surrounded by H, CH3OH. Correct or not? Then on the left hand side is the CH2OH, right? Can read condensed formula or not? Okay, let's continue. Okay, now the COH, again I break. Okay, what is a condensation reaction? Condensation reaction is a reaction whereby a simple molecule will be produced as a side product. So the simple molecule here is actually your water. Look at the pattern. The COOH is the one that contribute the OH. The ROH is the one that contribute the H. So the H and OH comes together and combine to form water as a side product. So the pattern is the ROH lose the H. The RCOH lose a OH. Okay? So you can only do this in the presence of a few drops of corn sulfuric acid. The corn sulfuric acid plays an important role, which is shown now. Okay? It is a reversible reaction when you react carboxylic acid and an alcohol together. So in the absence of catalyst, the reaction is very, very, very slow. So how do I speed up the reaction? How do I speed up the reaction? I add a catalyst. Okay? So the few drops of corn sulfuric acid is a catalyst. That's why I only need a few drops because it will be regenerated at the end of the reaction. Dehydrating agent. What is the purpose of dehydrating agent? To remove what? Water, right? So for those that can think a bit faster, remove water, what will happen to the POE? What is POE? position of equilibrium. So POE will shift to the right. So few drops of corn sulfuric acid, increase rate and increase yield. Okay. Okay. Remember the pattern. When an acid reacts with alcohol in a few drops of corn sulfuric acid, the OH from the COH comes out to combine with the H that comes from the ROH to form water and the ester. So, can you work out the products for the bottom equation? Remember the pattern. OH comes from the RCOH. H comes from the ROH. OH and H combine to give you water. Then the rest combine to give you the ester. Okay, done. Let's check what you have written. It should be this. Okay. My advice after marking my classes assignment is that some of you think you know how to draw structure using condensed formula. My advice is, if you think you are not confident with what you have written in condensed formula, don't do it. Okay, just draw everything out. The A-level question will not say that you must express your answer in condensed formula. Okay, I repeat that again. But they expect you to be able to interpret the structure based on the condensed formula that they print out in the question paper. You get what I'm trying to say, right? They will never say, write your structure or draw your structure in condensed formula form. They won't. But they can print out the structure in condensed formula, but you must be able to interpret. Get what I'm trying to say? So for this question, please don't mark yourself correct first. Can you please examine how the condensed formula is written before you give yourself a tick? Okay? And if you don't know how to write condensed formula, I will say it's okay. Then you just draw the thing out, okay? What is the ester functional group? Who can tell me what's ester functional group? C double bond O, and the C that is bonded to the double bond O is also bonded to a O. Correct or not? That is your ester functional group. Okay, can you see the ester functional group on the right hand side is C double bond OO. Can you see or not? Then it's flanked on the left and right hand side by alkyl groups, R and R prime in this example. Correct or not? That is your ester. Okay, that is your ester. Don't worry, we will have a topic on ester. Two lectures down, I think. So this one. Please check that what you have marked yourself correct or what you have marked yourself wrong is indeed the correct structure, okay? Okay, reaction with acyl chloride. Okay, this reaction, again, you will generate something called an ester, okay? C double bond O and O, okay? Now look at the pattern. Just now when carboxylic acid was reacted with alcohol, what's the pattern? The ROH, which is the alcohol, contribute the H. The RCOH contribute the OH, right? In this case, the ROH will also contribute the H, but the acid chloride, also known as your acyl chloride, because there's no OH, right? It contributes the Cl. So the H and the Cl come together to give you the side product called HCl. So what is this type of reaction called? This type of reaction is also called a condensation reaction. This is also a condensation reaction. Just that the previous example, the side product is water. In this slide, or in this case, the side product is HCl. Okay, this is also an example of condensation reaction. Okay, then some of you may be wondering, what is that weird looking thing that look like a benzene but it's not a benzene, correct or not? Because there's an N that is part of the 6-membered ring, right? Can you see that thing at the bottom? That is not a benzene, huh? That is actually your pyridine. Then what does it actually do? It actually helps to remove the acidic HCl gas that was produced in this reaction, okay? So you don't have to know it. Okay, that compound at the bottom is called pyridine. Okay, pyridine is not part of syllabus, but that pyridine is to help to remove the HCl gas that is produced, in case you want to know, okay? Now, in comparison to the previous reaction, right? Previous reaction, you take carboxylic acid and alcohol, you need to carry out in the presence of a few drops of corn sulfuric acid, remember or not? What does the few drops of corn sulfuric acid do? Catalyst and dehydrating agent, right? Remember? If you look at this reaction carefully, the previous reaction was a reversible arrow. This reaction is irreversible. So, if I'm a chemist that is very interested in you, which reaction do I prefer to generate ester? I will choose this reaction because this is an irreversible reaction. Can you see the bottom line? The reaction goes to completion. What is it trying to tell you? Obviously, this one here, the yield will be higher, right? Compared to the one where you use your few drops of corn sulfuric acid. Okay, so as practice, can you fill in the products? There's a product for you to fill in, right? In your notes, there's a blank there. So you just remember the pattern. The H comes from the ROH. Then the Cl comes from the acid chloride or the acyl chloride to form the side product called HCl. Okay, ta-da, quite easy, right? Okay, again, my advice is, if you're not confident of writing the product in condensed formula, don't worry, just draw everything out, okay? Show the dash to represent the CH bond, all those things, okay? Okay, done? Okay. Okay, this is your favorite oxidizing agent, right? You have been using this for like 2 weeks already, correct or not? What is the favorite oxidizing agent? KMnO4, then you prepare it by dissolving in dilute H2SO4AQ, remember? What is it used to test for? Cannot remember. SO2 gas, remember? So what if I change the medium from acidic to alkaline? Instead of turning from purple to light purple or colorless, it should look something like this, which looks disgusting, right? So the disgusting thing that you see here is your brown MnO2 solid, okay? Okay, so this is, okay, wait. What do you get when you oxidize alcohol? I think Mrs. Pua briefly mentioned in the previous lecture, talk about alcoholism and how alcohol damage your body. What does the enzymes in the liver oxidize alcohol to form a functional group? Can remember or cannot remember? It can either form carbonyl compounds or further oxidation can result in carboxylic acid. Okay, actually, This is where I like to end for alcohol because of the previous lecture group that suddenly there is a bell. You should know why. So in order to moderate my speed, right, I have to stop for my alcohol lecture. I have to think of something for you to do. Please take out your writing materials. Come and attempt the question. Hey, hello. Writing materials include your pencil box and maybe your A4 writing paper, which I think a lot of you should have spare A4 writing paper today, right? Free, right, at the entrance of RV. You don't think I don't know, huh? Don't tell me no paper. Some of you even took more than 2 pads, think I don't know. Shh. Okay. These are questions that touches on your recently concluded topic of alkyl halide. But the problem is organic chemistry is one big family, so it won't just impact on alkyl halide, so it will also impact on other functional groups. Come, can you solve? What? You can whip out your notes, what? No, 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 it's a solvent, inert solvent. It's not CCl4, I agree. Yeah. inert solvent, you don't have to care. Know what? Trichloromethane. Very good. 很好嘞，他们有背耶。The inert solvent. Yeah, yeah, it's okay lah, but they don't know, right? Okay, I know what's maybe part of the problem. Trichloromethane bochap is an inert solvent like CCl4, okay? It's not the same as CCl4, but it's an inert solvent, okay? Inert solvent. Huh? 什么东西？不可以站太靠近它，我一站靠近它，我 fall sick the other day，所以我要，yeah。I really fall sick 哎，ask my 要 fight off 嘛，它的 virus 我已经 fight off 了嘛。Just go through。Shh. Hey, I thought the first question was supposed to be the easy one. So maybe I will first go through. So suggest a possible formula for A. Bromine in trichloromethane. I say trichloromethane, you don't have to care about it, right? It's like your CCl4 is an inert solvent. So Br2, they never say UV light or anything. That means not FRS. So what can react with Br2 readily, which you have just learned, or two lectures ago? Your alkene functional group, right? So there's a CC double bond. You add Br2 into the CC double bond. What is the mechanism called? Hey, what's the mechanism called? Electrophilic what? Addition, right? Once you have introduced the the two Br atoms into A, which is the compound in the middle, then you look at the compound on the right hand side. You have now two CC double bond. So what do you call this reaction? You remove, in this case, two HBr molecule. So it's an elimination reaction. And if you memorize, it's ethanolate KOH or NOH, heat under reflux, right? I know in your notes there is a very long and bombastic name that some of you will try to say. I agree that can be the correct answer. It's called dehydrohalogenation. Rings a bell or not? But my advice is during test and exam, can you don't write that word or not? It's so long that I also don't like to mark it. Elimination of HX is easier. 对不对? Elimination of HX is simpler to write, right? Okay? Okay, done? Okay, I have another question for you. Come. This one will be harder, confirm. But more straightforward. This slide will serve as some form of a bit of revision for alkyl halide. So first, can you draw out 2-bromobutane? And this question tests you on 4 chemical reactions for bromobutane. Okay, let's review the answers. Let me change to. Okay, NaOH, AQ, and heat is a nucleophilic substitution reaction. What happens is your OH minus go in and kick out the Br minus, okay? Whether it's SN1 or SN2, I'm not concerned because the question just asked me to write down the products, right? And you don't even need to balance equation. They never ask for it. Alcoholic NaOH or alcoholic KOH, heat under reflux or heat, your purpose is to remove the HBr. Okay, removal of HBr. And if you follow the SAZEF rule, you should give me the major product, the one with the most number of alkyl groups attached to the carbon that is part of the CC double bond. What is ethanolic KCN? Again, it's a nucleophilic substitution reaction. The CN minus go in and kick out the Br minus. Okay. Last one, excess NH3 heat in a sealed tube is also a nucleophilic substitution reaction. Basically, the NH3 go in and kick out the Br minus, and in the process, it also loses a H plus, which combines with the Br minus being kicked out to form the side product called HBr. Okay. So if you think this is hard, then I tell you, actually, this is one of the more simpler questions you can attempt already. Just recall and apply. Okay, that will be all for this lecture. Reminder, next Monday is your test.